Hi guys, I am Asif Ali and you're watching CGHOW video, and today I will create this hexagon grid effect in Unreal Engine Niagara. So let's start this. First of all, subscribe my YouTube channel and also click on bell icon so you will receive all new video notification. So start this with creating a Niagara particle system, and I'll take this fountain and rename it Hexagon Grid, and I'll open this, and I have this fountain here, so I'll just hide grid and the particle count, and I'll remove all these forces. I don't need those, and I don't need spawn rate either, and I will use a grid spawn particle on grid, and then it required a grid location, so type grid location, and now you have the particle grid. It's a box, so I don't need on z direction, and I will make this z0, and let's make the life constant like 10, and also 10 loop, so it's infinite. Now I have this grid of particle, but I want hexagon, so I need to use a mesh of hexagon. So in Maya I quickly make a slender, and then I'll reduce the sides. So I have this hexagon now, and I will also reduce the height, and I'll scale this, and I'll move this up on the grid, and my pivot is on the grid now, so I can scale this from here. Okay, so I will save it and just freeze this and export this to the desktop. Let's say hexa, and just export it. Here in my folder hexagon grid, I will import that desktop, and where's my hexa. So I have this mesh, and I'll quickly use in here. Remove this sprite render and take the mesh render. Select the mesh and pick. Now I have this here, and just need to change the size because this is bigger. So I will make it 0.5 and maybe 0.3. So now you can see I have a hexagon grid, but this tiling is not the way that it should be, because if you follow my tutorials, yesterday I just posted a tutorial, and this is my tutorial, this hexagon, and you can see the tiling of hexagon in thumbnail. This is created in material, but now I'm doing it in Niagara particle system, so I need this type of tiling, and you should watch this tutorial. This is also from scratch, and you can just create this in material also. So here what I need these alternatives, this second and fourth, and then these rows should be moved a bit, so I can offset these. And how to offset these alternate? So I'll make a quick material like this color. You need to visualize first, you need to visualize these rows, then you can just offset those. So I'll take a particle color here, particle color, just connect it here. So now I have this color, and I can change color from here, but I will not change from here. I will make a module here, scratch pad, and let's say I'll take a position of particle, and I have now position, and I want to set the colors of these according to the position. So if I take the color here and break this, And let's say if I connect X directly here and apply, you can see, let me just change the background because background is also black. So let's make this gray, dark gray. Now you can see, oops, that doesn't save. Why? Okay. So now you can see I have black and white according to the position, but I want alternative black and white. So to do that, if you know, if you worked in material and if you checked my tutorial, previous tutorial, last tutorial about these hexagon trails, hexagon grid actually. So you will be find my nodes familiar here also. So let's say I want to offset this black and white color. So in materials you need to add, and I will add here also. So let's make a float and add. I just name it add so that will be easier for you because I'm adding some value on this and apply. Now you have this module here and you can, if I just pause this, I can move this. Now this is very sharp black and white. So first I will fade this, then I will use a frac so I can have a fractional value according to the position of this. So let's say if I divide this now and I will make another float, and this time I call it divide and connect it here, connect it here. So now I can fade this value. You can see it's fading. Okay. So let's say this is like the actual value that I found perfect. Although you can change the value, but add should be 61 and this should be 150. So I have this gradient and now I need to multiply it with a higher value, then use a fraction. So if I show you in material how it works, that will be easier for you. So you have a you have this gradient mask and you want a black and white strips. So what you will do, you can do two things. If I apply, you can use Sine, that will do for you. You have now strips, you can increase or decrease, or you can multiply this value with a higher value and then use a fractional value of this. And if I multiply this, you have these rows. So same thing I am using here. So now I have this gradient here. I am multiplying it with the higher value and I will make a parameter. Again, let's call it mul. This is my multiplier. Oops. And then fractional value of this. Hit apply. And the best value I found here is 112. And you can see closely, this is gray, this is white, this is gray, this is white, this is gray, this is white, this is black, this is gray. So it's almost there, not the perfect, but that will work for you, I think. So now you have the color and now you know which rows you want to offset on y-axis. So let's not use this color now. So I will delete this and I will delete this color and I need to offset the position, so I will take the position and break this, make vector. So I have already x, I need to offset my y according to this gradient. So let's multiply this with a value, and the value I will make a float again, and now I name it offset because this time I'm offsetting this, and add this on my y value, y position, and this will be my y and z will be the same, and hit apply. Now there is nothing because offset value is 0, and when I move this, you can see rows are offsetting accordingly. If I put 9 here, it will be your hexagon grid. And now you can increase the size so it will fit, and then you can play with this. So let's say I make this red 5.2, or I can randomize this 0 and 1. I have random. And now one more thing you can do, you can animate the scale, like scale, and oops, not scale color, scale size. And on Z axis, if you break this 1 1, and on Z axis you can animate this. So I can use a sine here, and if I make it 100, not 100, 10, 20, if I play, it will animate, but altogether I don't want that. So I will make this 20, so it's just offsetting from 0 to 1, and I want to randomize it, so I'll randomize the time. First I need to use the age from my normalized age, and then I will randomize the time, so it's random 0.2 and 2. So now it's looking cool, and I'll make this 10 and 10. It's looking really cool. Let's make it 1. More thing you can do with this, if I turn off the scale for now, and let's rename this like 1, and duplicate this, and this will be a 2. And here what you can do, you can use this non-uniform and 0.4 0.4, and you can increase, and now you can decrease 0.3 0.3. Now you have stepping, you have steps, you can increase, decrease more. We have now step, but these second step has different color. I want same color. If my bottom hexagon is green, I want upper one also green. How would you do that? You can just borrow the color from this. So to do that, I will create, it has already a scratch module, but I will create again, and let's say I will take a reader attribute, and I want get color by index, and I take execution index for each particle, and I want color, and I want to set my color. Hit apply, and here you have to put the name of first emitter, that is 1, and now color are same. And if you want same color but different what do you say, boost, you want brighter red, brighter blue, upper one, so you can add, or you can multiply, you can add some value, so like color strength, and add this on the color that you are borrowing from another emitter, and now you have this, and you can just brighten the color, maybe 0.1 0.01 0.02, slightly 0.05, and you can do the same as much as you want. So if I again duplicate this time this will be 3, and I will here make it 0.1 0.1, and make this more brighter 0.1. So now I have 3 stepping. Let's make this one 0.3 0.3, and this one 0.2 0.2. Now this looks better, and now you can turn on this but now this time it has random scaling, so you can borrow the scaling also if you want. So if I just turn on first, this looks cool this way also, but if you want the same scaling on this but slightly more, so I can remove this, and first I will just turn this off and again make a scratch module. Again I'll take a reader, although you can make a reader in emitter, update, then use the same, but I will just create an vector, get vector by index. This time I will take a scale every particle, and I want to edit the scale, update the scale, but this time I want to add or remove some value also, so I will add a vector. Let me check if it works and type 1 here. So now I think the same scale is taking, so I want to decrease some scaling. So first I want to add some scaling in Z, add it, then I'm going to decrease some scaling, so I want minus 0.2, minus 0.2, and same. And now you can just duplicate this scratch module here also, and here I will make this 1 and make it minus 0.4, minus 0.4. Does it work? What happened? It was working, but now not working. Okay, minus 0.4, minus 0.3, minus 0.3, and then 1. So now I have this, and that is looking very nice, and you can increase as much as you want, like 20, 20, and 20, 20, and 20, 20. And if you see this in Viewport, that looks this. Looking good. Let me full screen. Let me just simulate. Oh, it's already simulating, and make it full screen. Now you can see it looks cool. So I hope you liked it, and that's it. And thanks for watching. Keep learning, and don't forget to subscribe my YouTube channel CGHOW. Bye bye.